Good day, everyone. Today we will explain lesson 6.2, analyze reflections. We studied before how to translate an image over the coordinate plane in figure to another place, and today we will study how to reflect any figure. As you see here in the graph here, we want to reflect, we put a pencil in the middle, and we want to reflect the triangle in figure 1 into the next side to be figure 2, and we will call it figure 2. Reflection here means I will consider the pencil as a mirror. So consider the pencil as a mirror. It's a mirror, okay? And we want to reflect the triangle in figure 1 in the opposite side, okay, to become figure 2. Okay, let's translate it. Actually, to translate it or reflect it, reflect here is the same as flip. So we flip the shape. We have to keep the following. When we try to flip the first side, which is this side, we keep the same distance between the side and the reflection line. So this line is called line of reflection, okay? So it's far away by one step from the line of reflection. So I will get far away from line of reflection in the opposite side by 1 square, exactly. So the next point is here. So I move this point. Then second point, it's far away. Its distance between it and the line of reflection is 1 step. So we will go to the next or to the opposite side by 1 step. What do you expect the third point? What do you think about the third point? It's far away. How many squares from it and the pencil? 1, 2, 3, 4, 5, 6, 7. It's 7 squares. So I have to count 7 in the opposite side. 1, 2, 3, 4, 5, 6, 7, and put the point. So this is a reflection, and I can connect them to get same shape, okay, same size, same angle size. So angle size here is the same as the angle here, and the angle here is the same as the angle here, and the angle here is the same as the angle here. So same shape, same angle, but in the opposite side. Okay? This is small brief about what we mean about reflection. Okay? Let's go and take the definition of reflection. Actually, the definition of reflection is reflection or flip is transformation that flips the figure across a line of reflection. So we call the line which we reflect over is the line of reflection, line M here in our example. Okay, the pre-image, which is the original image, this one, okay, and the image. So after we reflect it, it become an image. And take care, always we call the image of any point by bar. So B, the image of B is B bar or B dash, A dash, C dash, and D dash, okay? So the image, always we give it dash over the letter to make difference between the original image and its reflection, okay? Okay, so and keep the pre-image and image are the same distance from the line of reflection, but on the opposite side. Yani same distance from line of reflection, okay, but in the opposite side. They have the same size, yes. CB equals C dash B dash. AB equal A dash B dash, and so on for all sides. Same angles. Angle B equal angle B. Angle A equal angle A. And so on. All angles are similar, okay? Have the same size, but different orientation. The only difference between them is the orientation. This one is in the left hand side, the pre-image, and the image in the right hand side. Okay, this is small definition also about translation. Let's take an example to apply it over examples. Our first example, we have a polygon A, B, C, D. Okay, A, B, C, D, E, 5 side shape. Okay, has a vertices A of coordinates of ordered pair -5 and 2. So A here, you go -5 from 0, we start from 0, over x-axis, and then up to 4, because it's each square here with 2 equal 2 unit, okay? So up 4, so A is here. And so on B, C, D, we locate them for the original image, which is the black one, and we want to reflect it to the image A dash, B dash, C dash, D dash over or across x-axis. So we want to make the mirror, or our line of reflection is x-axis, this one. As we said before, we have to keep the distance between the pre-image and the line of reflection the same as the image. So E, 2 step. So E dash, 2 step 2. A, 2 square. So A dash, 2 square 2. And so on. D, 1, 2, 3, 4, 5, 5 square. So D dash, 5 square far away from the line of reflection, and so on until we finish each point, okay? And I'll give you a small note about how to finish it without using the graph, or to confirm about yourself. Actually, if the point was A, -5 and 2, its reflection A dash over x-axis is what? I'll give you the rule. If you reflect over x-axis and the point is x and y, any number x, any number y, just change the sign of y. So leave x as it is and change the sign of y. Only. Let's try it here. For A, the point A is -5 and 2. So leave x, so it's -5. Change the sign of y, it's -2. Let's see over the graph. Is A dash is -5 and -2? Okay, -5, yes. And down -4. It's -2 or -4. Sorry, A is 2. Yes, it's the same distance. 2. As you see, -2 here, it's -2 here. Yes, excellent. So the same, so I can mention the point by using this rule. Okay, mister, is this rule for x-axis only? No. I'll give you the rule of y-axis. If we reflect over y-axis, so the point is x and y, and we reflect the image over y-axis, who can expect the point A dash, if this point is A dash will become what? Leave the sign of y and change the sign of x. So -x and y. Leave y as it is. Change the sign of x only. Okay, so if you reflect over the y-axis, leave x as it is, and if you reflect over the y-axis, leave y as it is, because it's reflect over y. So leave y as it is, okay? And change the sign of x. And if you reflect over the x-axis, leave x as it is and change the sign of y. This is the rule. Try to solve it. Okay, because we won't solve the right one now without drawing it, yes, we can find the image or the reflection images without using the graph. How? Let's solve that right. Quadrilateral KLMN has vertices at K equal 2 and 6, L 3 and 8, M 5, 4, and N is 3 and 2. It is reflected across the y-axis. We will reflect over y-axis. What is the rule? Hey, if it's x and y, the point, the original point, x and y, over y-axis, leave y. Change the sign of x. That's it. Okay, let's do it for each point. Okay, he asked for what is the coordinate of n dash. So start with n. N equal, in the original, n is what? 3 and 2. What about the image after we reflect it over y-axis? Yes, n dash. Leave y as it is. Okay, it's 2. Change the sign of x. It's 3, it will be negative 3. That's it, this is the image. I can do it for all the points. Okay? Okay, let's take another example. This example is how to reflect over y-axis. In the last example, it was reflection over x-axis. Now, how to reflect it over y-axis? The same, by the same rule. Okay, D, the original point D, axis of symmetry here, all axis of reflection is y. Okay, so we will keep the distance between each point and y. Okay, the distance between D and y is 1 square, so we will take the same in the opposite side. So it will be D dash, added D. A, 1, 2, 3. 3 steps, okay, and from the line of reflection, and then 3 also in the opposite side. 1, 2, 3, so it's A dash. And so on for each point. This is from the graph. Can you do it from the coordinate? Let's take an example. How about the point C? C was what? Let's see. C coordinate is, the point C is what? 4 at x and down negative 2. So it's 4 and negative 2. We want to reflect it over y-axis. So leave y as it is. Leave y, it will be negative 2. C dash. And x, change the sign, negative 4. So it will be negative 4 and 2. Let's apply it over the graph and see if it's right or not. Yes, C dash equal, as you see here, it's 4 at x, negative 4 at x, and negative 2 at y, the same as we calculate. Same. Okay, always we reflect over x-axis and y-axis only? No, I can reflect over any line. Any line in the world, you can reflect. You can consider the mirror, you can put the mirror at any place. Vertical, horizontal, slope, it has some slope, okay? So you can reflect over any position, okay? Let's take the next example to explain what is the meaning of what we said. Polygon ABCD is the right one. Okay, we are reading the right one. Polygon ABCDE reflected across the line x equal negative 2. What is the line x equal negative 2? We studied in the last quarter. What is the straight line x equal negative 2? How to draw it? X negative 2 is a line parallel to y-axis. Yes, and the cut x-axis at negative 2. So it's line parallel to y-axis and the cut x-axis at negative 2. So this is a line of symmetry or line of reflection. Okay, let's draw it. That's it. We will reflect over this line because the equation of this line is x equal negative 2. Okay. So let's keep the distance between the shape and the other shape. We will draw the other shape, point by point. B, one step from the line, then one step here, it will be here, in the opposite side. A, two square here, it will be here. So it's A dash, B dash, okay? We'll make it bigger something, okay? Okay, so A dash, B dash, okay. What about C? C, one step from the line of reflection, it will be one step. So it's C dash. What about D? 1, 2, 3, 3 step from the line of reflection, it will be 1, 2, 3, 3 step of the line, it will be here. D dash. Let's connect with take care about the order of letters. Don't connect A with C. No, it's wrong. So it's A, B, C, D, and close the shape. Okay, so we reflect the same shape. Okay, sorry for my handwriting. Drawing, you should do it by ruler actually, but I want to make it fast, so you must do it by ruler, not by your hand. Okay? Okay, so it's the same shape but in the opposite side. So same size, same angles, same shape, but in the opposite side, different orientation. That's it all. Okay? Okay, let's move to solve some exercises about this lesson. Okay, draw the reflection of trapezoid ABCD across the y-axis. Okay, let's first identify the original points or pre-image points. The pre-image is the blue one. Oh, okay, A equal here what? Someone tell me the coordinate of A. So point 8, yes, it's 2 over x-axis and then 8 over y-axis, so it's 2 and 8. Okay, that's right. You don't have to draw the coordinate. I just mention it by my hand to know what I'm doing. Okay, so next one, B. Yes, it's 6, 8, 6 and 8. C, it's 8, 3. What between 2 and 3 here, 2 and 4 here is 3. So take care about it. So 2, 8, and 3. What about D? 1 at X and 3 at Y. 1, 3. Okay, the reflection over what? Y-axis. What is the rule? Leave Y. So always we will leave Y. It's 8 here, 8 here, 3 here, and here is 3. Change the sign of X. -2, -6, -8, -1. We already locate the point. We determine the point, okay? Now we want to locate it over the coordinate plane. Okay, let's start with D. D, 1, and it will be -1 and 3. It will be here. This is D dash. It will become D dash. Okay, next, A. A, from A to -2 and 8. -2, 8 up, it will be here. As you see here, the distance between A dash and A, this is A dash, and A, the same. Yes, 2 distance. 2 square from the line of reflection. Okay, what about B? 6 and 8, it become -6 and 8. -6, so it's -6 here, and 8 up 8, it will be here, so it's B dash, okay? And the last one is C, and its coordinate, the new coordinate is -8 and 3. -8 up 3, it will be here. So it's C dash, okay? Let's connect them together. As I told you, you have to use the ruler. We will try to use the ruler here, okay? A with B first, as we said, keep with the ordering, A with B. Okay, then B with C. Then C with D. Okay, and last, D close the shape with A. That's it. We already reflect the shape with the same size, same shape, but in the opposite side by different orientation. That's it for today. I hope you enjoyed the lesson. See you. Bye.